Hi, I'm back washing clothes. No generator, no battery. And if you saw my prior video, I installed this system and had it sort of makeshift for a while. I've been running it for about a week and really like it. So I've just installed the panels up on my roof today. So let's look at those. I built this garage about 10 years ago, all by myself with my wife. And I was a lot braver then, I guess. This is a really steep roof. It's 9/12 pitch, and it's rather precarious installing those panels. They're kind of heavy, but we got them up there. It's two 280 watt Trinas, 60 volts in series, and those panels are in series with my other 60 volt array. So I got 120 volts out of those sets of panels. These panels themselves, there's just two of them, but they're going to provide about half the daily wattage that is produced, even though the rest of my array is around 2,000 watts. Most of them are heavily shaded. They're in the sun for a while, and then it moves to other ones, and they actually face southwest. But yeah, that was a lot of fun. So if you remember from my last video, this was the inverter I used, and I removed all the 12 volt up to 150 volt boost converter components, and I run this thing strictly on DC coming in, and I provide 12 volts to the control electronics. But I was straightening out the wiring and did it with the power on, and things shorted out. So yeah, that blew out one FET, and I replaced that. Then I blew out two more FETs, and I thought, well, I should investigate further. And it was an A42 PNP transistor. It's a 300 volt. I have them in stock at home, but not here at the camp. So it was just cheaper to go to another inverter. And here's what I have. This is a 2,000 watt Harbor Freight. This is one of the older ones. And I bought a whole bunch of these, and usually, one portion of the H bridge has some shorted FETs, and I don't even bother replacing the FETs. I just wiggle out the shorted ones because they're doubled up, and they work. 1,000 watts then, but that's more than I usually need. So this one is I bring out wires, so I'm feeding the high voltage capacitor with around 145 volts, and I supply 12 volts to the control electronics to keep that alive. That's only about 50 milliamps. And I have this little this is a 12 volt 1 amp power supply. These things are only like $1.50 shipped from China, and it's a cheap solution. They'll run on DC. I use them all over. I buy them a dozen at a time. So here I have a bypass diode arrangement. This is for the I have an additional 12 volt panel in series with everything, just to boost up the voltage a little bit, because at power point in the sun, these 60 volt panels are going to produce around 55 volts, and that's really too little voltage to be driving everything with a square wave. So I boost it up. It gets around 140 then. I have some sense electronics to see when the 12 volt panels start getting shade. They're really prone to shade, but and below is some Anderson PowerPoint power connectors. These replaced a QS60 switch that I had, which shorts out. I'll come up with something different later, but yeah, I move it over to one side, and the 60 volt array is in parallel with the other one to give me really good morning sun. And I can put the panels in series, one to run the washing machine when needed. And that only happens from about 10 o'clock in the morning till I don't know, 11:30. Actually about 9:30 you can start. But the system works, and no batteries. Just feeding the voltage right in. Occasionally a big cloud will come over and it'll shut down, but you know, you wait for the cloud to pass and you can restart the machine. It remembers where it was. But the system works. A lot of fun. Thanks for watching.